Welcome to Chapter 5, Database Processing. I am going to cover some of the highlights of Chapter 5. One of the topics that's covered is what is the purpose of a database? And that is to organize and keep track of things, to keep track of multiple themes, and there's a general rule of thumb that if you just have a single theme, you can store it in a spreadsheet, but if you have multiple themes, a database might be better. I would imagine that most of you have used a spreadsheet at some time or another, so you're probably familiar with that, but maybe not a database. Here's an example of a spreadsheet that is a list of student grades. And so we have the student name and number, and then what their grade is on their various homework assignments and midterm grades. And so this is a single theme. In the next example, we see an example of a database. And this is multiple themes. And so at the top, you see that you have the same information that was stored in the spreadsheet, the student name, the number, and their various grades. But then there's also two other themes that are contained here, and that is emails that have been sent and also office visits. So there's essentially three different themes that is being stored in this database. Now, for many of you that have used spreadsheets, you're probably thinking, well, I can do that in a spreadsheet as well. And I will say that many times the same thing can be accomplished with a spreadsheet versus a database. It just depends on what your application is, which one is the best choice. Databases do provide, well, I'm going to jump to that in a minute. First, let's look at an example of how things are stored in a database. So things are stored in rows called records and columns called fields. And those are the basic concepts and terminology of a database. And then the hierarchy of data elements in a database is at the high level you have a table. And so within a database, you might have multiple tables, and then within each table, you have rows, you have columns, and then the bytes or characters are just the actual data that's stored in those rows and columns. If we look at this example shows relationship among the rows of a database. And this is one of the examples where a database might make it easier to view and manipulate this data than what a spreadsheet would. And so you'll see we have the student table. That's the one in the middle. So that's kind of the main table with the student names and the student numbers. And then up at the top you have the email table, which has all the emails that were sent to that student. And there's a link from the student number down to the student table. So you'll see for each row in the student table, there can be one or more rows in the email table. That's called a one-to-many relationship. And then down in the office visit table, although there's only one row there for that student, that could also be a one-to-many relationship also, because a particular student might visit the office more than once. And so when you have relationships like this among the rows, typically a database is easier to store that data. Now again, Excel is a very powerful spreadsheet, and there's a lot of things that you can do with Excel. So I'm not saying that this can't be done with Excel, but many times it's easier with a database. All right, so what is a database management system? You also often hear that referred to as a DBMS. And it is a program used to create, process, and administer a database. And typically these are licensed from different vendors such as IBM, Microsoft, Oracle, and many others. Some examples are DB2 from IBM, Access and SQL Server are both offered from Microsoft, and Oracle Database is the database from Oracle. And then there's also another one called MySQL, which is an open source, license-free database that is available as well. When you talk about databases, there's essentially 4 types of operations that you can perform on a database. You can read a row, you can insert a row, you can modify an existing row, and you can delete a row from a database. Those are the basic functions of a database. The language that you use to manipulate SQL databases anyway is a language called SQL, which stands for Structured Query Language. It's pronounced SQL. It is an international standard that's used, and it's used by most popular DBMS systems. And there's an example there. We're not going to learn SQL language in this class, but this is an example at the bottom of how you would insert information into a database called student, and it would insert information for that student, the student number, and what grades they received on those assignments. So if you've done any programming or you've seen programming languages before, it looks kind of like that. Another topic that this chapter addresses is how do database applications make databases more useful. And so we talked about the database itself, and some of the examples we used were Access, SQL Server from Microsoft, Oracle has one, DB2 from IBM, but each of those has a database application that sits on top of it. And that database application it essentially enables you to create a collection of forms, reports, queries, and other programs to serve as the interface between the user and the database data. Because most users are not going to be skilled enough to go directly into the database and manipulate data. So you're essentially going to write an interface with the database application that's going to do that for you. And that application can also provide security, help maintain data consistency, and other special cases that might be needed by the application. So what you typically see with one of those database applications is some type of forms application that enables you to create a form so people can insert data into the database and look at and view data in the database. Reports, which enable you to pull data out and do reporting from the database. Create queries, enabling you to query against that database. And then application programs, which would be, which provides the security, the data consistency, and if you think of maybe the example of, for inventory, you might create an inventory application that enables you to do all the things that you need to do with an inventory database. Another topic that I wanted to cover at a high level, and again, my goal for this class is to expose you to terminology and things at a high level that might come up in your everyday world when you're at work and you get involved in situations that involve technology. And so you may hear the term a NoSQL database, or sometimes called a non-SQL or not relational. So this is the opposite of a relational database. So it's not SQL Server, it's not Access, it's not DB2, because it's not relational. And these type of databases, the purpose of them is to support very high transaction rates. They have a relatively simple data structure and they're more flexible. One of the challenges with a relational database is sometimes the structure of the database can be somewhat constricting or restricting as far as the data that you want to store. And these non-SQL databases are also designed to scale across many servers. Really, with the advent of the internet and the cloud, that is how these became so popular. If you look at some examples, Amazon, Google, Facebook, all have some version of a NoSQL database that they are using. My guess is, unless you're really into technology, you've probably never heard of any of these names. But that's what those companies are using in the background to process their data. There's another one called MongoDB that is commonly used among a lot of different corporations now. You may have heard about sometimes MongoDB is used in conjunction with Hadoop. But for example, the company that I work for right now, traditionally we've had all SQL databases. It's all been Microsoft SQL Server. And we have recently embarked upon a project to convert a lot of our data over to MongoDB, to a NoSQL database, because that gives us more flexibility and it can also process that data faster. And so in the long run, our company is actually going to have a combination of both of those types of databases. We'll have some SQL and we'll have some non-SQL. So the question becomes, will NoSQL replace relational databases altogether? Probably not. First, the conversion to non-SQL is very expensive and disruptive. It's very technical, and it's limited to people that have a very deep background in computer science, whereas relational databases are a little bit easier to use and manipulate. Again, I think in the case like with my company, I think what will happen is organizations will probably choose a combination, and the NoSQL products will probably be used for very specialized applications. The last topic that I wanted to touch upon was the concept between a spreadsheet and a database, and I touched upon this at the beginning. And you know, when do you use one versus the other? The book does a pretty good job of walking you through an example of when someone might want to use a spreadsheet over a database. But it really depends upon your users and what the requirements are. Typically, if you see a database project that has failed, it's probably because the people, the resources that were running the project, either doing the business analysis around the project or maybe actually developing the database, probably didn't have the skill set that they needed, or maybe the project was unfunded. A lot of times, you know, in that analysis phase, maybe the communication between the end users and the developers was not handled right, and therefore the requirements were not clear, or there was a lack of requirements, or maybe the project just wasn't managed well. So many times if a database project fails, it's maybe not necessarily because the database was the wrong choice, but maybe the right resources just weren't necessarily on the project. Some other things to keep in mind is that databases do take time to build. They have to be maintained and operated. You typically need IS resources to create them and to keep them running. So depending on your organization, if you think that you can accomplish what you need in a spreadsheet, and IS resources are something that are scarce at your company, and you don't feel like you're going to have IS resources to support your database, then a spreadsheet might be the right choice for that, especially if the data needs are simple. With Office 365 now, it's very easy to share spreadsheets, and so you can provide access to your spreadsheet to multiple people, and that might satisfy the needs that you have. So really the key between choosing between a spreadsheet and a database is really to understand what the requirements are, to understand your audience, and then also just to understand what kind of support resources potentially are available to support that. And I believe that was the last slide. Thank you.